we'll look, as the last aspect of weather, at patterns relating to pressure and winds. Starting to think of what pressure is. Pressure we think of as the amount of force per area. So, for example, I am putting pressure on the area of the desk by leaning on both hands. I am putting much more pressure on just a small area if I put all my weight leaning on just one finger, putting more on a smaller area. This was rather vividly described for my high school physics class. The professor for it recalled back roughly his high school days when he went to prom and his date managed to step on the toe of his shoe with a spike heel and poked a hole in the shoe. Not because she was excessively heavy, but all her weight concentrated on that little spike and made a hole there. There are a number of units used. We tend to use either atmosphere or bar in meteorology because one of those is close to an average air pressure, but you encounter various others. Pascals are the standard metric or system international unit. Pounds per square inch would be the standard using the English units, millimeters of mercury, things like that. Here are the numbers, not that you have to know them, but they're there if for some reason you need to look them up. Again, a bar is 100 kilopascals, and that is reasonably close to average atmospheric pressure. You see 1 atmosphere is 1.01 so forth bar. So 1 atmosphere is a little more than 1 bar, but both of them are pretty close to pretty standard atmospheric pressures at Earth's surface. Pressure relates to other aspects. We'll see this in the cloud lab, but pressure, volume, temperature, and how much stuff you've got are related. This is the formula. Not that you have to memorize it, but if the formula helps you remember, great. If not, then don't worry too much about it. Pressure times volume equals N, the number of atoms or molecules we've got, times R, which is just a constant to make the units balance out, and times temperature. And so what this tells us is if something here, say if pressure goes up, we need either volume to go down or something on this side to go up. So two things on the same side of the equals will tend to go opposite each other, inversely related. Things on either side of the equals will tend to both go up or down together. So for example, put more pressure on something, or you can imagine, say we had a balloon, put pressure on it, squeezed it, yeah, that would make it smaller. So pressure going up, volume down. If we increase the temperature, well then we'd have some combination of either our volume expanding, if our container were stretchy, say a balloon, we heat it up, it would tend to expand. Or if our container is not stretchy, increasing our temperature could increase the pressure. Of course, we could have both volume and pressure going up, some of both changing together. Higher pressure will tend to go along with higher temperature. Lower pressure with lower temperature. We went over that quite a bit with our adiabatic labs. Right. If air is rising, it's got less air pushing down top of it, so it's under less pressure, and so it tends to expand its volume and lower its temperature with lower pressure. There are a couple of ways we can think about pressure. One, hydrostatic. That's thinking of the pressure as basically the weight of all the air that's on top of you pushing down. Earth has gravity, of course. Yep, still works. So air is pulled by that gravity and it is pushing down on us. Now, of course, we're feeling it all the time, so we don't particularly notice it. You do notice if you have extra high or extra low pushing on you. For example, if you were to be exposed to pressures like up in the mesosphere or thermosphere, you'd burst because the pressure inside you would be not balanced by the pressure outside, and you would notice that at least for a little while. Or conversely, underwater, all that extra weight of water, higher pressure, you do feel that. Another way of thinking about pressure, molecular, all the atoms in the air zipping around, and some of them are bouncing off of you all the time, and each little bounce of an air molecule puts a little pressure on you. Adding those up is another way of thinking about the air pressure. Both of them are valid. It depends on what aspect you're thinking of as to which model might be more helpful in understanding what pressure is doing. For example, again, what would change pressure, increasing or decreasing it? The activity pictured here is tending to put some pressure on the bed. What would tend to increase that pressure? Well, of course, one thing, if instead of kind of you go more for something like go faster, that would be more pressure. The equivalent for gas would be higher temperature. As those molecules are zipping around more, they're bouncing off of you more vigorously. Of course, another option would be invite some friends over. Lots of them all jumping on the pin. That's going to be more pressure too. Likewise, if we stuff more molecules into our same space, we'll get more pressure. Again, maybe helpful in understanding the patterns. Okay. Pattern with altitude. We looked at this a little bit way back with the first lab. I mentioned it from time to time since then. Sea level, the pressure is about 1 atmosphere. Atmosphere is defined as your average sea level pressure, a little bit over 1 bar. As you go up, the atmospheric pressure goes down. So, sea surface, in just over 100 kilopascals, 5.6 kilometers up. A tall mountain will get you there. That's down to half just by going up the mountain. And actually got examples of that over here. Grab them from going up mountains. Klingman's Dome is the second tallest mountain up in the Appalachians, right near the Tennessee-North Carolina border. And here's a water bottle where it was up at the parking lot there. Open the water bottle. So the pressure inside the bottle matched the air pressure on top of the mountain, and then screwed the lid on tight and drove it back down here. And you can see how squished up the bottle is because the air pressure here is noticeably higher. It's kind of interesting having the car and hearing the crackling noise as it squinched down. This one's even more squished. This one was up out in Colorado, and so they've got taller mountains, got up higher. Again, open the bottle, then screw the lid on tight with air inside being at the pressure up there. And then now let's back down here again. The air pressure is rather higher and our bottle is noticeably squished. A device for measuring pressure is a barometer. The first effective barometer was invented by Torricelli, pictured here. You can probably figure out there's a connection between his name and the torr unit of pressure. And what he found was if you fill a tube up with mercury, it helps if you're living back in the 1600s, don't know how poisonous mercury is. And then turn that upside down into a dish of mercury. The mercury will sink down some, leaving a space in the top of your tube, a vacuum there, but you'll still have some in the tube. That is because the air pressure on the rest of the mercury balances out the pressure of the mercury there. And so if you do this, it turns out that your mercury is about 760 millimeters tall. And so you get pressures referred to as, say, millimeters of mercury or centimeters of mercury, inches of mercury. That's referring to a barometer like this, how much the mercury is pushed up. One other thing about mercury, besides being rather toxic, especially if it's not just a pure metal, but into chemical compounds, mercury is great at dissolving other metals. and so add mercury to a metal, you tend to be getting it in the mercury rather than as your solid piece of metal. This is not a good thing if you are relying on that piece of metal. It is highly illegal to take mercury into an airplane with you, for example. You do not want a drip of mercury landing on your airplane and making a hole in it. If you are a certified meteorologist and have a special reason to carry the barometer, you can get special certification, but it is something that does require being very careful with.